Dear students, I just want to work out some more problems on the compound angles which I had mentioned in the previous session. So, in this session also I am going to prove certain result in which I will be making use of the compound angle formula. Let me take up the first problem. Prove that tan of pi by 4 plus x divided by tan of pi by 4 minus x. You have to show that it is equal to 1 plus tan x the whole square divided by 1 minus tan x the whole square. So, this is what you have to prove now. That is, the left hand side we are having the tangent function, right hand side we have to show that it is 1 minus tan x or 1 plus tan x the whole square and 1 minus tan x the whole square, or it can be given like this also, 1 plus tan x divided by 1 minus tan x whole square using the law of the identity, law of the indices. So, here it can be given taking both the numerator denominator to the same power, or it can be given individually like this. Now, let us start with the left hand side, and here let me do the expansion. It is of the form tan of x plus y. The compound angle formula is tan of x plus tan of y. X means pi by 4, y means x, divided by 1 minus tan pi by 4 into tan x. Now, write this middle line a little longer. Now, take this one, tan of x minus y. The terms are same, only the sign are different, isn't it? That is tan pi by 4 minus tan x divided by 1 plus tan pi by 4 into tan x. So, this is equal to, now look, see, we have made use of the compound angle formula, have expanded numerator denominator. Now, I come to the standard angle part. Tan pi by 4, what is pi by 4? 45 degrees. Tan 45 is a standard value, it is 1, you know the value. That means you can write 1 plus tan x, 1 plus tan x divided by 1 minus 1 into tan x. Write this line. Again, denominator 1 minus tan x divided by 1 plus 1 into tan x. Now, students have the tendency of cancelling these two, because one is in the numerator, the other is in the denominator. It is not so. Both of them, no, they come to the denominator position. This term being the denominator of the denominator goes to the numerator. Now, 1 into tan x, you can write tan x, here also same thing. So, what I do is, I write it as 1 plus tan x divided by, numerator part I am writing, over 1 minus tan x. Now, instead of division, I write it as into. You might be knowing that one. Then this gets reciprocated. That means it goes to the numerator. This is in the denominator. That is 1 plus tan x. The denominator of the denominator would be going to the numerator, and this 1 minus tan x in the denominator. Don't get cancelled, these they don't get cancelled here. Now, nothing is getting cancelled, they are getting multiplied here. 1 plus tan x the whole square divided by 1 minus tan x the whole square. Hence, we get the right hand side. Okay, we get the right hand side. So, you have to be familiar with all the results here. It may be standard angles, it may be compound angle formula, it may be allied angle, whatever may be that one. When you are familiar with all the results, no, whichever formula we need here, we can use that result to solve the particular problem. We move on to the next problem. Sine of, here you have to be careful, sine of n plus 1 into x into sine of n plus 2x plus cos of n plus 1 x into cos of n plus 2 x. You have to show that this is equal to cos x. Now, in the previous session, I had given you one problem where the left hand side resembled the formula cos x into cos y minus sin x into sin y. This is also of the same type. The difference is in the previous problem, what I did in the previous session, we had a minus sign, here it is plus sign. And the number was known number, pi by 4, 3 pi, like that. It is an unknown quantity here. Look at the result here. First, let me write in the proper order starting with the left hand side. I want to write in the standard form. That is, write this term first. Cos of n plus 1 x into cos of n plus 2 x plus sin of n plus 1 x into sin of n plus 2 x. See, n plus 2 means it would be some number. For example, cos 2x into cos 3x plus sin 2x into sin 3x, something like that. In the place of 2, 3, 4, the exact number, unknown quantity has been given. That's the only difference. N plus 1x, n plus 2x, n plus 1x, n plus 2x. Now, you observe this is of the form cos x cos y plus sin x into sin y. What is this formula? Cos x cos y plus sin x sin y is nothing but cos of x minus y, the compound angle formula. See, you can quote this result. We know that cos x into cos y plus sin x into sin y equal to cos of x minus y. Write a sentence here. This left hand side resembles the formula cos x into cos y plus sin x into sin y, which is equal to cos of x minus y. What is x here? X means this angle, y means this angle. So, let me write that one. So, this is equal to cos of x minus y. Write properly. N plus 1 into x. This is x minus n plus 2 into x. This is y. So, this is x and that is y. Compare them. Now, this would be equal to, now inside the bracket, inside the square bracket, remove this one. It is n into x plus x, 1x, minus n into x and minus 2 into x. Correct? Now, you observe plus nx minus nx, they get cancelled. 1x minus 2x is equal to cos of minus x. Now, I am using another result here. Cos of minus x, cos of minus theta is equal to cos theta, or it is cos x, which is the right hand side. Or if I had taken here n plus 2 in the first place, n plus 2 into x minus n minus 1 into x, we would not have come across the minus sign there. Directly we could have written. Even now, though we have written in the same order in which it has been given, we get cos of minus x, but you know that cos of minus theta is cos theta plus cos theta. There is no change of sign here. Now, this is one problem, which of course the same type of problem we did in the earlier session also, only the difference was in between we had the different sign, that is all. Dear students, it is a different type of problem I am giving you now. Look here, two ratios have been given to us. sin x is 3 by 5. See, it is a valid value but not a standard value. And the other one, cos y is minus 12 by 13. As you know very well that the values of sin x and cos x always should lie between minus 1 and plus 1. So, both of them are valid, but we do not have any stand like 45, 30 degrees, it is not so. So, two trigonometric functions have been given to us, and it is the other condition is both x and y are in the second quadrant. So, the angle lies between 90 degree and 180 degree, both the angles. That is why sin ratio has been given as a positive number and cos y has been given as a negative number, because in the second quadrant cos is negative and sin is positive. What is our problem is, you have to find the value of sin of x plus y. So, you can expect such, instead of sin x plus y, they can ask you to find out cos of x plus y, or both of them can be asked, or cos x minus y, sin x minus y, or tan x plus y, any ratio could be expected. Now, here to see, when a ratio is given means two sides of the triangle would be given. To know the other value, here if you expand this one, it has sin x into cos y plus cos x into sin y. We know only sin x, so we should get cos x. We know only cos y, we should get sin y. For that, no, in the earlier sessions I have told you how to find the value. You always draw a triangle and do not mark any sign in the triangle. Let me consider the first triangle where I mark the angle as x. Now, it is sin x, opposite is 3, hypotenuse is 5. When you calculate this now, it becomes 4. We have come across such same values actually. So, it is using the Pythagoras theorem, 5 square 25 minus 3 square 9, that is 16, root 16 would be equal to 4, or you can show the calculation also. Next, you come to the other information, mark the angle as y. Now, here it is cos y is 12 by 13, do not mark it as minus 12 here. Now, adjacent side is 12, the hypotenuse is 13. So, when you use the Pythagoras theorem again, 13 square is 169 minus 12 square 144, you get 25, root of 25 would be equal to 5. Now, you can take them as A, B, C, P, Q or also. Now, come to the expansion of this one. It is sin x into cos y plus cos x into sin y, isn't it? Now, it is not left hand side like this. I am considering the given expression, given the compound angle formula. Now, look here, both the angles are in the second quadrant. So, sin ratio will be always positive. See, from the first triangle, I have sin x equal to 3 by 5. It has been already given to us. Let us consider cos x. Now, I have not written any sign here, but you know that x is in the second quadrant means cos would be negative. The same definition holds good, adjacent over the hypotenuse, it is minus 4 by 5. If you have the values here, directly you can substitute there. Come to the second triangle. Here, sin y. Y is again in the second quadrant. Sin is positive means it is 5 divided by 13. And cos y already has been given to us with the negative sign. It is minus 12 by 13. This and this were given, this and that we have written here. So, when you have all the values here, substitute sin x, that is 3 by 5 into cos y, that is minus 12 by 13, negative number right inside the bracket, plus cos x, it is minus 4 by 5 into sin y, we have calculated to be 5 by 13. Now, it is minus 12 3s are 36, 13 5s are 65, minus 5 4s are 20 divided by 65. Of course, 5 can be cancelled. I am not cancelling, keeping it as it is. Now, let me take the LCM. Why I am keeping that as it is means the common denominator becomes the LCM. So, what is the LCM here? 65, and both of them are negative, minus 36 minus 20, that is minus 56 over 65. Here we are not proving any result, we are getting the value of the expression. So, the value is minus 56 divided by 65. So, this is so. So, each problem will be a little bit different. Students, this problem we are working out it as a problem, but you can use this as a standard result also. Sometimes when you go to other branches of mathematics, we may come across this product sin of x plus y into sin of x minus y, or it can be sin of a plus b into sin of a minus b, like that. So, the right hand side would be sin square of the first angle minus sin square of the second angle. Now, we are going to prove this one using the expansion of sin x plus y, sin x minus y, and also the basic identity, that is sin square theta plus cos square theta equal to 1. So, it can be given for either 2 mark question, or wherever you want to, you can use. If it is given like this, you can write it as a product. If the product is given, you can write it as the difference of the 2 functions. Now, let me start with the left hand side and expand sin of x plus y. What are the terms here? Sin x into cos y plus cos x into sin y. Okay, one expansion into the same thing, only the sign is different. Sin x cos y minus cos x into sin y. Now, look at the terms inside the 2 brackets. You may remember your high school formula, it is of the form a plus b into a minus b. So, what is the answer? A square minus b square. A square means the square of the first term, that is sin square x into cos square y minus the square of the second term, it is cos square x into sin square y. So, you can write, if you want you can write, otherwise it is a basic formula I am using. So, a plus b into a minus b, a square minus b square. Look at the right hand side. I do not want any cosine term at all. So, this I do not want and this I do not want, isn't it? How to eliminate? We cannot simply erase it, isn't it? Therefore, using the identity, I can write like this. Keep that sin square x as it is, cos square y, using the first identity, sin square theta plus cos square theta equal to 1, I can write it as 1 minus sin square y. Write minus, again this cos term not wanted, and using the same identity, I can write it as 1 minus sin square x. Close the bracket, write this as it is. And many students, they forget to multiply both of them, multiply them properly. Now, this is sin square x into 1 and sin square x into sin square y. Okay. So, this is over. But remember, we have a minus sign, both the terms should be multiplied by this function also. Minus 1 into sin square y is minus sin square y. Minus of minus plus sin square x into sin square y. Sin square x into sin square y. We clearly observe that this product is repeated. One is with a positive sign, the other is with a negative sign. So, what is remaining now? It is sin square x minus sin square y, which is the right hand side. And I told you this is, though we have worked out it as a problem, you can consider it as a formula. Wherever you want to, you can use this result because it is treated as one of the standard results. So, I worked out problems which are connected with the compound angle formula. In the coming sessions, I will be taking up the next type of angle, that is known as multiple angles and also submultiple angles. So, these are different names given. First compound angle, using that we learn about the multiple angle, then we come to another formula called as transformation formula. So, in the coming sessions I will be teaching you about the multiple and submultiple angles. Thank you.